Hello, calculus fans. Okay, so we've got two cars driving on some boulevards. There's a scofflaw, person trying to get away from the police. They're driving northbound on the boulevard, and they're 0.2 miles north of an intersection. Now the police, they're in hot pursuit. They're 0.3 miles west of the same intersection and driving towards the intersection. Now the police are driving 80 miles an hour. Now the police are also holding a radar gun. And this radar gun, what it measures is how quickly the distance between the cars is changing. So basically there's a line of sight between the police and the car that they're pursuing. They can measure how fast that distance is changing. Now the radar gun is reading negative 25 miles per hour. So the distance between the cars is getting smaller at the rate of 25 miles per hour. So we want to know how fast is the scofflaw driving. Now we're going to create some variables here. So x is going to be the distance between the police car and the intersection. Y is the distance between the scofflaw and the intersection. And then z is going to be the distance between the police car and the scofflaw, this straight line distance between the two cars. Now, probably the best thing to do is to draw a simplified diagram. Okay, so here's our simplified diagram without any of the fun stuff in there, like the overhead picture of the car and all that. So we've got the x, y, z in to denote our distances. Now let's write down the information that we were given in this problem. Okay, so we know that x is equal to 0.3. That's the distance between the police and the intersection. We know that dx by dt is negative 80. Now 80 represents how fast the police are driving. And then there's a negative on that because the police are getting closer to the intersection. The quantity x is getting smaller. That means dx by dt is negative 80. That minus sign is important. We have to have that in there. We're told that y is equal to negative 0.2. That's the distance between the scofflaw and the intersection. Let's see, we don't know dy by dt. We also don't know z. But we do know that dz by dt, that was the rate of change of the distance between the two cars. That's the thing that was measured by the radar gun. That's negative 25. And again, we have to have the correct sign in there. The negative 25 is because, the reason it's negative is because the distance between the two cars is getting smaller. Now there's a difference between these two unknowns. Z, the reason that that's unknown, this unknown here, that's unknown because it just wasn't given to us in the problem statement. Whereas dy by dt, the reason that's unknown is because that's the thing we're trying to solve for. So we're not going to be able to figure out dy by dt without using some calculus, but z we can. All we need to use is the Pythagorean theorem because we're dealing with a right triangle here. So our triangle in that diagram is a right triangle. So we know that x squared plus y squared equals z squared. And so if we plug in the values of x and y, those distances that we know, we can get a value for z. So z is the square root of 0.3 squared plus 0.2 squared. And that all works out to 0.13. Now let's take that equation that relates the variables, which is x squared plus y squared equals z squared. That's going to be useful to us more than just solving for z. That's an equation that relates the three variables in question, so that's the thing that we should be differentiating with respect to t. So we're going to differentiate both sides with respect to time. See what that gives us. So we get 2x times dx by dt plus 2y times dy by dt plus, or equals 2z times dz by dt. Notice that each one of these we have to apply the chain rule because we're differentiating with respect to time. We'll just cancel out the 2's, we don't need those. And now let's plug in everything, at least the things that we know. So let's see, we know x, we know dx by dt, we know y. We don't know dy by dt, that's our unknown quantity that we're going to solve for. We've now calculated z, and we know dz by dt. So actually we know everything except for one variable, which is the dy by dt. That's good. That's the thing we're trying to solve for. So when we plug in everything that we know, 0.3 times negative 80 plus 0.2 times dy by dt equals radical 0.13 times negative 25. All right, now it's easy to solve for dy by dt. So if we do that, then we get an expression that looks like this. And that's pretty close to 75 miles an hour. Okay, that's all for now.